At present, there are 10 Hyperledger projects in incubation, comprising 5 frameworks and 5 tools. Frameworks represent different approaches to building enterprise blockchains. Here's a brief overview of the main ones. Hyperledger Fabric. Originally proposed by IBM, Hyperledger Fabric aims to provide a modular, scalable, and secure foundation for industrial blockchain applications. Fabric is a base layer core infrastructure for Hyperledger projects. It exemplifies the modular architecture we described earlier, in order to allow components such as consensus and smart contracts to be plug-and-play. Hyperledger Sawtooth. Sawtooth, a project initiated by Intel, delivers another modular platform for distributed enterprise applications. It involves a novel consensus algorithm called Proof of Elapsed Time, or POET, which is optimized for efficient simulation of the Bitcoin proof-of-work consensus in a trusted corporate environment. The Sawtooth white paper goes along familiar lines. Today's business processes for information sharing are burdened with intermediaries, inefficiencies, and security concerns. Through the use of distributed ledger technology, or blockchains, business processes between companies can be streamlined, and records can be kept in sync without the need for a central authority or manual reconciliation processes. This can help enterprises to reduce their costs and enable them to create entirely new ways of doing business. Sawtooth is a framework for building distributed ledgers for enterprise use with a focus on modularity and extensibility. Sawtooth builds upon decades of state-machine replication research and is designed to support any consensus mechanism or smart contract language. The authors also give credit to Bitcoin and Ethereum as inspiration for Hyperledger Sawtooth. Have you heard this line of thought somewhere else before? Yes, it was expressed by the R3 Corda team, another permissioned enterprise blockchain focusing on the financial sector. Good, seems we are on the right path with the milestone projects we are covering. The evolutionary process of deriving new enterprise blockchain solutions from the leading public blockchains is described neatly as follows. Since the release of Ethereum, a variety of other distributed ledgers implementations have been created to meet the needs of the enterprise. These distributed ledger implementations include software that expands upon existing protocols, for example, Bitcoin and Ethereum, and creates entirely new implementations, Corda and Fabric. The Sawtooth architecture has 5 core components: peer-to-peer network for passing messages and transactions between nodes, distributed log, which contains an ordered list of transactions, state machine smart contract logic layer for processing the content of those transactions, distributed state storage for the resulting state after processing transactions, and consensus algorithm for achieving consensus across the network on the ordering of transactions and the resulting state. These 5 core components resemble the 5 forces powering Bitcoin, which we examined in detail earlier in the course. Sawtooth has a permissioned network in order to control who can connect, send transactions, and participate in consensus. Also, some default smart contract templates are provided. They are divided by function and grouped into transaction families. This is an innovative idea. There are smart contract templates for managing network settings and off-the-shelf marketplace and supply chain solutions. There is also a tool for integrating Ethereum smart contracts with Sawtooth. Users can develop further their own smart contracts and transaction families. This approach is a little different from what we find in general-purpose smart contract platforms. In Ethereum, for example, the same generic instruction set, also known as opcodes, is used for all types of applications. So, smart contracts for financial services, media, supply chain, healthcare, and so on would use the same toolbox of programming commands. Whereas in Hyperledger Sawtooth, each transaction family has its own smart contract logic comprised of operations specific to that domain. This makes Sawtooth programming both restrictive and secure at the same time. With a smaller code base, flexibility of what you can do is restricted, but also the probability of costly errors is smaller. This design choice follows a similar logic to why the programming capabilities in Bitcoin were restricted from the outset. Furthermore, Sawtooth enables developers to write smart contracts in a variety of languages such as Python, JavaScript, C++, Rust, and Go. It is also flexible regarding virtual machines, and both the Ethereum and Java virtual machines can be used. Sawtooth does not take a fundamental position on which consensus mechanism is best. It rather offers an interface that allows for a variety of consensus protocols to be used. We can broadly distinguish two main approaches to consensus protocols: lottery consensus and voting consensus. The first, known as Nakamoto consensus, elects a leader through some form of lottery. The leader then proposes a new block to be added to the blockchain. In Bitcoin, for example, the first miner to solve the proof-of-work cryptographic puzzle wins the leader election lottery. The second approach, also known as Byzantine fault tolerance, uses votes among consensus participants to elect a leader. The novel consensus algorithm Sawtooth proposes and adds to its stack is proof of elapsed time, or POET for short. It is a Nakamoto-style consensus algorithm designed for trusted enterprise environment. It allows a leader node to be elected randomly based on the time that the node was waited before proposing a block. POET provides similar distribution of results to other lottery algorithms such as proof of work in Bitcoin. The probability of election is proportional to the resources contributed. In this case, resources are general-purpose processors, or CPUs, with a trusted execution environment. Code and data loaded inside the trusted execution environment are protected with respect to confidentiality and integrity. So, basically, POET emulates the proof-of-work mining process in Bitcoin with CPUs in a trusted environment, which minimizes system resource requirements. This is possible in Sawtooth because all network participants are known and trusted by default. By contrast, participants in open public blockchains such as Bitcoin and Ethereum don't know each other and don't have to trust each other. In summary, the key innovations introduced by Sawtooth are the domain-specific smart contract layer and the POET consensus algorithm. They are essentially modifications of the Ethereum virtual machine and the Bitcoin proof-of-work consensus protocol. The project is neatly summarized by the team itself as follows. Sawtooth is a blockchain platform designed for enterprise usage. Sawtooth builds upon the learnings of platforms before it, such as Bitcoin and Ethereum, and is designed with a focus on modularity and extensibility. Sawtooth is unique from existing blockchain platforms in that it allows developers to program their smart contracts in a variety of traditional programming languages. Future Sawtooth developments will focus on increasing the throughput and privacy of transactions. Okay, let's move on to the other notable Hyperledger projects. Hyperledger Iroha builds a library of reusable components with focus on mobile development. These components include libraries for digital signatures, hashing algorithms, transaction protocols, peer-to-peer communication protocols, APIs, Apple, Android, and JavaScript development tools. Hyperledger Burrow is a permissioned smart contract platform which can integrate with the Ethereum virtual machine, EVM, in order to run Ethereum smart contracts and distributed applications. It provides interoperability between Hyperledger and Ethereum. Hyperledger Indy is an identity management system. It develops tools, libraries, and reusable components for providing digital identities rooted to blockchains that can be used across different administrative domains and applications. All right, this will do for now. We'll present some examples of Hyperledger implementations in various industries later on. Next, we'll have a look at another notable project, the Enterprise Ethereum Alliance. See you in the next section.